I'm going to go over exercise 14 and what you need to do to complete this exercise. So I have the worksheet here that I've created for you to be able to type your answers into. You can also type them in your own document if you would prefer. Let's start with number 1. According to the study narrative in figure 1 in the Flanagan et al. Study, does the APLS UK formula under or overestimate the weight of children younger than 1 year of age? Provide a rationale for your answer. So here they just want you to show that you understand what that formula is. So look at what the formula is. It's listed in figure 1. And see if you think, if you plugged numbers into that using those values, is this going to underestimate or overestimate the weight of children? Remember, with regression, we're trying to find the best predicted value. We're trying to make the best prediction that we can. So if we use this formula, do you think it's going to be a pretty good prediction or not? Number 2, using the values A equals 3.16 and B equals 0.502 with the formula in figure 1, what is the predicted weight in kilograms for a child at 9 months of age? So here we just need to plug in these values that were given into the formula. And I went ahead and put the formula here. So this is the formula that's listed in figure 1. Y, so our predicted value, equals bx plus a. So I'm going to take this a value and plug it into the equation here. And I'm going to take this b value and plug it into my equation there. So let me just show you what that would look like. So that b value goes here, where the b is in the equation, and then this a value is going to go here, where the a is in the equation. And then the value I have here is for a child at 9 months of age. Now remember, when I have a number with an x next to it, I'm going to multiply this number times whatever my x value is. So my x value here is 9 months of age. So I'm going to put 9 here. Remember, this is going to be multiplied. And then the last thing I need to remember is my order of operations. It's just implied that there's parentheses here. So I'm going to do this multiplication first. I'm going to multiply b times my x value, and then I'm going to add my a value to that total. So just make sure you do that in the proper order of operations. So that's how you would set up this formula. For 3, we would do the same thing, except we're using 2 months of age. So here, for my x in my formula, instead of 9, I'm going to put a 2 there. In figure 2, the formula for calculating y is weight in kilograms equals 0.176 times age in months plus 7.241. Identify the y-intercept and the slope in this formula. Okay, so this just wants me to identify which value represents my intercept and which represents the slope. So the formula we would be using is weight in kilograms equals 0.176x, which is my age in months, plus 7.241. So remember our regression equations, and they're just stating it a little bit differently, but here's my regression formula. And remember that this value by itself is your slope, or I'm sorry, is your intercept. And this value that we're multiplying times the x is the slope. So this is telling me where it crosses the y-axis. And then this is taking into account how steep that line is and multiplying times what my x value is. Okay, so identify in this formula then which one is the slope and which one is the intercept. Remember, the slope takes into account how steep that line is, and it's going to be multiplied times my x value. Number 6, using the values a equals 7.241 and b equals 0.176 with the formula in figure 2, what is the predicted weight in kilograms for a child 3 months of age? So the formulas that we have in figure 1 and figure 2, They're both regression formulas, but they have slightly different values for slope and intercept. So it's the same formula, but here my values for my slope and my intercept are a little bit different than they are here. Okay, so come back to this one. I'm looking for a value for a child that's 3 years of age. So I'm going to use this formula where I'm multiplying my slope times age in months. So I need to figure out 3 years of age in months, and then I'm adding my intercept to it. So just plug the values into that and solve it. In figure 3, some of the actual mean weights represented by the blue line with squares are above the dotted line for the formula, but others are below. Is this an expected finding? So if you recall back to our lecture, we talked about how regression is trying to fit the best line through that data that it possibly can, but it's not going to be perfect. So we're going to have some errors, where the error is the difference between our predicted values and our actual values. So we would expect to see some above and below because we're not making a perfect prediction. We're trying to find the line that best fits what that data is. And if you're confused about this, look back at the slide on scatter plots and refer back to the scatter plot practice where we had the dots and the line is trying to go the best it can through the middle of those. Number 8, in figure 3, the novel formula is weight in kilograms equals 0.331 times age in months minus 6.868. What is the predicted weight in kilograms for a child 10 years old? So again, same formula, but we have different values for our slope and our intercept. So all we need to do is plug in the information into this formula. So our weight in kilograms is going to be equal to 0.331 times age in months minus 6.868. So just plug your values into that. Number 9, was the sample size of the study adequate for doing linear regression? Provide a rationale. So do some analysis of what you think about the sample size here and if you think it was adequate sample size or not. Number 10, describe one potential clinical advantage and one potential clinical problem with using the novel formulas presented in figures 1, 2, and 3 in a PICU setting. So again, these were all regression formulas, but they had different values for the slope and intercept, which is why they looked a little bit different. So just use your knowledge of nursing and health in general to see what you think about what could be a potential advantage or disadvantage to using those formulas to predict weight. Okay, so we have different regression equations here with different intercepts. One may be better than another at predicting. What they don't give us here is the p-value, so we can see if this was significant or not, but we can do some analysis just with the calculations that we got and what we think was better at making a weight estimate. And then why is it important in this setting to be able to make a weight estimate? And that's what you need to do for exercise 14.